I'm going to go through the answers to the cricket problem that we did in class. First of all, I would enter the data for chirps and temperature into my Nspire in the list and spreadsheet page. Then I made a scatter plot, did a linear regression. So you can see here's the regression equation. And then I also did a regression on the calculator page. And you can see here also the regression equation and so forth. And that's how I get my R squared and my R value. Now the second question says to interpret the slope and the Y-intercept. And so I'm going to look at that for a second here. The slope would be interpreted if the number of chirps per minute goes up by 1, the temperature goes up by 3.2 degrees on average. Or for every 1 degree increase in temperature, for every 1 chirp increase, we expect the temperature to increase by about 3.244 degrees. So it seems like a chirp is associated with about a 3.2 increase in temperature. The Y-intercept says when crickets stop chirping, 0 chirps per minute, the temperature is predicted to be about 26 degrees. My feeling is, though, when the crickets stop chirping, the temperature is probably much higher than that because they're going to be dead by 32 degrees. Just saying. Okay. How do we, now we're going to use this to do some predictions. So let's get my calculator out here. If I wanted to predict the number of cricket chirps at 17 degrees, I'm sorry, other way around. If I want to predict the temperature at 17 cricket chirps, I would predict about 81 degrees. If you look in the actual data, you will see that 17 cricket chirps was 83.5. So we have a residual, actual minus predicted, of 2.3 chirps, or 2.3 degrees, sorry, which means that the temperature predicted is less than the actual temperature. If we looked at that on our scatter plot, so the 17 degrees here, let me see if I can find the 17 degrees. There it is, 17 degrees, 83.5. You would see that that point is above the line, 2.3 degrees above the line. So positive residuals, remember, are above the line. That means that they are higher than predicted. Negative residual values would be below the line. Those would be lower temperature than predicted for that number of chirps. No data is recorded for a cricket at 18 chirps per second, so we're going to use our model to predict that. And once again, if I go to my calculator page, there's 2 ways I can predict. I can actually use the equation with the slope and y-intercept that are shown. So here's my slope is 3.24417 times 18 chirps, which is my x value, plus the 26.012 y-intercept gives me 84.4. Or I can type in F1 of 18, which does this automatically, and get 84.4 degrees. When I interpret, or when I predict something within the data, that's called interpolation. And I'll talk about that with the graph in just a second. Sorry, a little glitch there. Always, my screen's kind of sensitive. If we predict the temperature for 22 doing the same method, we would get 97.4. Predicting a y value for an x value that is outside the domain of the data is called extrapolation. So let me illustrate what I'm saying when I say the interpolation and extrapolation. Notice my data has chirp numbers from 14 up to 20. There isn't anything lower than 14 or higher than 20 in my x values. So when I predicted 18, I was predicting within the data that I already have. When I was predicting 22, using 22 chirps, I was predicting outside the range of the data. That's called extrapolation. Now the next thing we're supposed to predict is what if, or according to the model, how many chirps per second are there when the temperature is at the freezing point? So if we were to extend this line down farther until we saw 32, and basically that would be putting 32 into our function for y. So we'd be saying 32 is equal to, and I guess I can do a solve here. 32 equals, I don't know if I can use F1. We'll try 3.24417x, oops, 17x plus 26.012 comma x. I think that's the correct way to do it. Yeah. So that's saying if we say x, our temperature is 32, and we want to find temp, and we want to find our temperature, and see our number of chirps, we would say the number of chirps that's associated with 32 on our model is 1.84. I suppose that seems realistic, although in actual fact the crickets would be dead at the freezing temperature, which I mentioned earlier. What are the and if we actually went lower than 32, we would probably end up with negative numbers of chirps, which obviously wouldn't make any sense at all. So extrapolation isn't always accurate. We say that it's dangerous because the pattern may not continue outside of the data, or the value may not be reasonable. So when we interpolate, predict within the data, we usually get a pretty reasonable prediction. When we extrapolate and interpret outside the data, the farther we go, the less accurate we are likely to be with that prediction.